Welcome back sa Mathusay General Math Tutorial. Sa lesson na ito, pag-aaralan natin kung paano sinosolve ang domain at range ng rational function. Let's start! Alam natin na ang rational function is a function of the form f of x equals p of x all over q of x, where yung q of x natin at p of x ay mga polynomial functions at ang ating denominator must not be equal to 0 kasi magiging undefined ang ating function. Ang domain naman ay set of all values of x where q of x must not be equal to 0. So alam na natin, pag sinabi nating domain, these are set of all values of x o mga inputs. Para ma-identify ang domain ng rational function, hahanapin lang natin ang value ng x na kung saan magiging 0 ang denominator. Kasi pag 0 na ang denominator, undefined ang function. At yun ang magiging restriction ng ating domain. Samantala, ang range ay set of all possible values of y or outputs. May dalawang paraan upang makuha ang range ng rational function. Algebraically, pwede nating hanapin ang domain ng inverse function. So, kasi ang konsepto nito ay yung domain ng inverse function ay equivalent sa range ng rational function. Or, we can just sketch the graph to determine kung ano ba ang domain at range ng rational function. Para mas maunawaan ang proseso kung paano sinosolve algebraically ang domain at range ng rational function, let's have these examples. Example number 1. Determine the domain and range of this rational function f of x equals 1 over x. So, ang unang-unang hahanapin natin is yung domain. Ang tanong, kailan ba magiging undefined itong function na ito? Alam natin magiging undefined lang ito kapag naging 0 ang denominator. So, ibig sabihin, x must not be equal to 0, right? So, ang domain na itong function should be the set of all x such that x must not be equal to 0. So, ibig sabihin, lahat na ng numbers, real numbers, ay pwedeng maging domain nitong function except 0. Klaro? How about yung range? So, to solve for the range of this rational function, gagamitin natin ang konsepto ng paghahanap ng domain of the inverse function. Kasi gaya ng sinabi ko kanina, ang domain of the inverse function is equivalent sa range ng rational function. So, ganito ang proseso, no? So, we have this function y equals 1 over x. So, ang una nating gagawin is to interchange yung ating x and y variable. So, kapag na-interchange natin yan, we have x is equal to 1 over y. Now, this time, we will solve for the new values of y. So, mag-cross multiply tayo, we have xy equals 1. So, to get the value of y, divide both sides by x, we have y equals 1 over x. So, ito na yung bagong value natin ng y. So, we will rewrite this inverse function as the inverse function of x equals 1 over x. So, ngayon, titingnan natin ngayon kung ano yung domain nitong inverse function. Take note, this is the inverse function of the rational function f of x equals 1 over x. So, ibig sabihin, the same lang. So, ngayon, ano bang domain nitong bagong inverse function natin? So, we know that it will be undefined if x is 0. So, ibig sabihin, ang domain natin ng inverse function na ito is set of x values such that x must not be equal to 0. Since gaya ng sinabi ko kanina, yung inverse function, yung domain nito is just the same with the range ng rational function. So our range will be the set of y values which are elements of real number except 0. So yun yung way na pag-solve natin algebraically ng range ng rational function. Let's take another example. Example number 2. Find the domain and range of f of x equals x all over 3x minus 9. Now in this case, to solve for our domain, kailangan nating i-solve, kukunin muna natin yung ating denominator and solve for the value of x. So in this case, we have 3x minus 9 equals 0. So to simplify this, we add both sides of the equation by positive 9. So kaya meron tayong 3x equals 9. Now this time, to solve for x, dividing both sides by 3, so x is equal to 3. So kapag ang x natin ay equal to 3, magiging 0 ang denominator. So in this case, magiging undefined yung function f of x. So ibig sabihin, ang ating domain is the set of all values of x, element of real number, such that x must not be equal to positive 3. How about yung range? Now again, we will solve it algebraically. So to find the domain of the inverse function, we have y is equal to x all over 3x minus 9. So ang gagawin natin ulit is to interchange x and y. So we have x is equal to y all over 3y minus 9. So magko-cross multiply na tayo. So we have x times the quantity of 3y minus 9 equals y. So this time, didistribute natin si x. X times 3y, we have 3xy. X times negative 9 is negative 9x equals y. So ngayon, dahil magsosolve tayo ng panibagong value ng y, mag-a-add tayo both sides of the equation by positive 9x. So ang mangyayari, we have 3xy minus y equals 9x. Kumbaga parang tinranspose na natin si y sa kabila, yung negative 9x naman tinranspose sa right side of the equation. So, we can pull out y sa left side ng equation natin. So, pwede nating i-factor out yan as y times the quantity of 3x minus 1 equals 9x. Since we want to find the new value ng y, so we have y is equal to 9x all over 3x minus 1. So, ang inverse function ng the function f of x equals x all over 3x minus 9 ay 9x all over 3x minus 1. So, ngayon, paano ba natin kukunin ang domain ng inverse function na ito? So, kailan magiging 0 ang ating denominator? Take note, kapag i-equate natin ang 3x minus 1 equal to 0, ang value ng x must be 1/3. So, in this case, pwede nating sabihin ngayon na ang range ng ating rational function is the set of y values such that yung y must not be equal to 1/3. Klaro? Example number 3. Find the domain and range of f of x equals x squared minus 9 all over x squared minus 2x minus 3. So, to get the domain, again, kukunin natin ang denominator at gagawin natin tong equal to 0. Kasi hahanapin natin yung values ng x na kung saan magiging 0 ang ating denominator kasi magiging undefined ang function. So, in this case, meron tayong quadratic equation sa denominator. So, mas mainam na i-factor out natin ang x squared minus 2x minus 3 equals 0. Ang factor nito ay the quantity of x minus 3 times x plus 1 equals 0. Ngayon, to solve for x, we have x minus 3 equals 0. Ang isa naman, x plus 1 equals 0. So, ginamit na natin ang zero product property. Now, to solve for x sa ating x minus 3 equals 0, mag-a-add tayo ng positive 3 both sides of the equation. So, ang value ng x is 3. Now, for x plus 1 equals 0, mag-a-add tayo ng negative 1 both sides of the equation. So, ang x natin will be negative 1. So, ibig sabihin, kapag ang x natin is 3, magiging 0 ang ating denominator. Undefined ang function. So, restriction siya. So, kapag x is equal to negative 1 naman, magiging 0 ang ating denominator. Again, restriction siya. So, ibig sabihin, ang set of domain na meron tayo ay set of all x such that x must not be equal to negative 1 or x must not be equal to positive 3. This time naman, ating isa-solve ang range ng rational function na f of x. So, in this case, mas mainam na i-factor out natin ang numerator at ang denominator para kung pwede nating i-simplify, mas madali nating mahanap ang range. So, in this case, we have y is equal to x minus 3 times the quantity of x plus 3. Yan yung magiging factor ng x squared minus 9. Samantalang ang factor ng ating denominator ay x minus 3 times x plus 1. So, in this case, mapapansin natin na pwedeng i-cancel out ang x minus 3. So, we have y is equal to x plus 3 all over x plus 1. So, ito yung gagamitin natin ngayong function to find the inverse function. So, we have y is equal to x plus 3 all over x plus 1. So, interchange lang natin ang x and y. So, x is equal to y plus 3 all over y plus 1. So, ngayon, i-multiply na natin si x with the quantity of x plus 1. So, we have x times the quantity of x plus 1 equals y plus 3. So, ngayon, multiply naman natin si x with y at x and 1. So, we have xy plus x equals y plus 3. So, again, since we want to solve for the new value of y, so, dapat si x ay mailipat sa kabila at itong y naman ay mailipat sa kabila. So, mag-a-add tayo ng negative x sa both sides of the equation at negative y sa both sides of the equation. So, we have xy minus y equals the negative x plus 3. So, ngayon, pwede nating i-factor out itong expression na meron tayo sa left side ng equation. So, pwede nating i-pull out si y. We have y is equal to the quantity of x minus 1 equals negative x plus 3. So, solving for y, we divide both sides of the equation by x minus 1. So, we have this inverse function na pwedeng isulat as inverse function equals negative x plus 3 all over x minus 1. So, ito yung inverse function ng ating original na rational function. So, ngayon, kailan magiging 0 ang ating denominator? That is, kapag ang x natin is equal to 1. So, ibig sabihin, magiging undefined yung inverse function. So, yun yung magiging restriction ng ating range. So, since ang restriction is 1, so ang range natin will be the set of y values such that y must not be equal to 1. So, again, you can solve for the range of the rational function algebraically using the concept of the domain of the inverse function. May mga times na kung saan hindi rational function ang given, kundi graph ng mismong rational function. Now, how do you determine the domain and range of the rational function given its graph? Now, let's consider itong ating example kanina sa number 1, ang function na f of x equals 1 over x. Ang graph nito ay ganito. Kung mapapansin natin, hindi lalampas yung graph natin sa line na ito, itong blue line, dash line na in-indicate ko, at hindi rin lalampas yung ating graph dito sa red dashed line. So, anong tawag sa mga linyang ito? Actually, kapag naghahanap tayo ng domain and range ng function given ang graph, ito lang yung titignan natin dahil yan yung magsasabi sa atin kung ano yung magiging restriction ng ating domain and range. So, itong line na ito ay tinatawag nating asymptote. Ano ba ang ibig sabihin ng asymptote? Asymptote is the line that the graph of a function gets closer but do not touch. Ibig sabihin, habang papalapit ng papalapit ang graph na ito, it will never touch this line. Ito naman, habang papalapit ito ng papalapit, hindi ito lalampas o magta-touch sa line na yan. So, may dalawang type tayong asymptote na nakikita dito sa example, no? So, itong blue one, ito, ay tinatawag nating vertical asymptote. Samantalang, ito naman, example nito, itong red dash na line ay horizontal asymptote. In this case, ang vertical asymptote natin ay x equals 0. So, ito yung imaginary line at x equals 0. Samantalang, ang horizontal asymptote naman ay line na kung saan ang y is equal to 0. So, ibig sabihin, ito yung magiging restriction ng ating domain and range. So, ano ang ipinapahiwatig ng ating vertical asymptote? Ang vertical asymptote ay magsasabi sa atin kung ano ang restriction ng domain. So, in this case, alam natin na ang ating domain ay set of all x values except 0. Kasi hindi naman siya lalampas sa line na x equals 0. Samantalang, ang horizontal asymptote naman ay nagsasabi sa atin kung ano yung restriction ng range. So, in this case, ang range natin will be the set of y values except 0. So, pareho lang sa example natin kanina. Now, let's take this example para mas maintindihan natin yung proseso na ito. Example number 4. So, sa example na ito, kung mapapansin natin, ito yung vertical asymptote at x equals 1 at ito yung ating horizontal asymptote at y equals 0. So, in this case, ang domain nitong graph na ito ay the set of x values such that x must not be equal to 1. Kasi ibig sabihin yan, kapag ang x natin is 1, magiging undefined ang function. How about yung range? So, by analyzing this graph, no? So, since ang ating horizontal asymptote is at y equals 0, so, ang ating set of range will be the set of y values except 0. So, ito na ang ating domain and range. Ganun lang siya kadali. So, again, titingnan na natin ang vertical asymptote at horizontal asymptote kasi yun ang magiging restrictions. How about example number 5? In this case, mapapansin ninyo na meron tayong dalawang vertical asymptote na kung saan ito ay mga line at x equals negative 3 at x equals positive 3. So, ang horizontal asymptote naman natin, kung mapapansin nyo, ay line at y equals positive 1. So, hindi agad natin basta-basta isusulat yung ating domain and range. Kasi kung mapapansin niyo, nahati sa tatlong region ng ating graph. So, in this case, paano natin kukunin ang domain ng graph na ito? So, again, Ang domain, titingnan lang natin ang vertical asymptote. So, mas madaling hanapin ang domain dahil ang domain is the set of x values except positive or negative 3. Kasi yan na yung vertical asymptote natin. Now, ang ating range naman ay medyo tricky. Kung mapapansin ninyo, yung ating range, merong sa taas, merong sa baba. Pero hindi lalapit sa line na y equals 1. So, may dalawang set tayo ng range. So, ang unang set ay lahat ng y values na mababa sa 0, including ang 0. Itong parabola nakapababa. So, kaya you have the set of y values such that y is less than or equal to 0. Union the set of y values such that y is greater than 1. Ito namang pataas. So, itong left side and right side ng ating vertical asymptote ay may range na lahat mas malaki sa positive 1. So, again, the range will be the set of y values such that y is less than or equal to 0 union the set of y values such that y must be greater than positive 1. Claro? How about example number 6? So sa example number 6, ito yung ating vertical asymptote at x equals 2 at ito naman ang ating horizontal asymptote at x equals 0. So madaling hanapin ang domain natin. So ang domain will be the set of x values such that x must not be equal to positive 2. Samantalang ang range naman natin will be the set of y values such that y must be greater than 0. Kasi tingnan nyo, hindi lumampas o hindi yan magta-touch sa ating line at y equals 0. So, yan yung domain and range nitong graph. Example number 7. So, kung mapapansin nyo, again, meron tayong dalawang vertical asymptote at wala tayong horizontal asymptote. So, in this case, ang ating domain will be the set of x values except positive or negative 3. Kasi ito naman ay line at x equals negative 3 at itong vertical asymptote naman is at x equals 3. In this case, ang range naman nitong graph ay set of all real numbers. Kasi lahat ng y values ay pinag-uusapan. So, wala tayong, again, dito sa graph na ito, wala tayong horizontal asymptote. Kasi obviously, lahat ng y values, either positive or negative, ay range nitong rational function. So, tandaan, kapag given ang isang graph ng rational function, ang dapat lang natin tignan ay ang ating vertical asymptote kasi yun yung magiging restriction ng ating domain at titignan din natin kung mag-e-exist o nag-e-exist ang horizontal asymptote kasi yun ang magiging restriction ng ating range. Klaro? So, may mga times din naman na kung saan mahirap hanapin ang range ng isang rational function. So, instead of getting the inverse of that given function, ang gagawin na lang natin is to sketch the graph. Kasi ang domain naman madaling hanapin eh. So, again, tandaan natin, kapag nag-i-sketch tayo ng graph, kailangan pa rin natin yung konsepto ng asymptotes. So, pag-uusapan pa rin natin si vertical asymptote at si horizontal asymptote. In this case, alam natin na ang vertical asymptote is the restriction of the domain. So, mas madaling hanapin si domain kaysa sa range. Sa paghahanap ng range, dapat alam natin kung paano kino-compute ang horizontal asymptote. So, kapag meron tayong rational function, di ba may leading term tayo sa numerator? Meron din tayong leading term sa denominator. Pag-uusapan natin yung exponent nitong mga leading terms na ito. So, kapag ang leading term, yung exponent ng leading term sa numerator ay mas maliit sa exponent ng leading term sa denominator, then the graph of the function f has the line y equals 0 as horizontal asymptote. Again, kapag maliit ang exponent ng leading term sa numerator kaysa sa denominator, ang horizontal asymptote ay automatically equal to 0. Y equals 0. Samantalang, kapag ang exponent ng leading terms ay equal, then the graph has a horizontal asymptote in the line y equals a sub n over b sub n. Ibig sabihin, kapag equal ang ating exponent, ang gagawin natin is we get the numerical coefficient of this leading term sa numerator and denominator, then we divide it. Ang last case naman, if n is greater than m, ibig sabihin mas malaki ang exponent ng leading term ng numerator kaysa sa denominator, then the graph of f has no horizontal asymptote. So again, kapag mas malaki yung ating exponent ng leading term sa numerator kaysa sa denominator, automatically no horizontal asymptote. Klaro? So we will use this concept in graphing or sketching the rational function. So, let's start. Example number 9. f of x equals x squared all over x squared minus 9. So, hahanapin natin yung domain and range nito. Sa domain, walang problema kasi pwede lang natin kunin ang factors ng ating denominator. So, again, if we graph this, no? So, una nating hahanapin ay si vertical asymptote. Pangalawa, si horizontal asymptote. So, ang vertical asymptote natin, kukunin natin ang denominator, isosolve natin ang value ng x. So, x squared minus 9 equals 0. So, we add both sides of the equation by 9, we have x squared equals 9, right? So, to solve for x, get the square root, so you'll have x is equal to positive or negative 3. So, ang vertical asymptote natin ay negative 3. Ang isa naman ay at x equals 3. So, yan na yung vertical asymptote natin. So, ibig sabihin, pag magdodraw tayo ng graph, hindi yan lalampas dyan. So, ang domain ng function na f of x equals x squared all over x squared minus 9 will be the set of x values except positive or negative 3. Kasi hindi na yan included. Klaro? How about ang horizontal asymptote? So, tandaan natin yung theorem kanina. So, ang leading term ng ating numerator ay x squared. Samantalang ang leading term ng ating denominator ay x squared din. So, ang exponent this time ay equal. Diba? N is equal to m. So, ang gagawin natin ay kukunin natin ang numerical coefficient ng numerator and denominator. So, ang numerical coefficient ng numerator is 1. Ang denominator naman is 1 din. So, 1 divided by 1 is still 1. So, ibig sabihin, ang ating horizontal asymptote is at line y equals 1. So, again, kung papansinin ninyo, nahati ang ating Cartesian plane or ating graph sa tatlong region. So, ngayon, kapag mag-i-sketch tayo ng graph, dahil meron na tayong guide, vertical asymptote at horizontal asymptote, magko-construct tayo ng table of values. Alam natin na ang ating guide will be lahat ng numbers na maliit sa negative 3. Ibig sabihin, itong left side ng ating graph. Lahat din naman ng numbers ang pag-uusapan natin na nasa gitna ng negative 3 at 3 at lahat ng numbers na mas malaki sa positive 3. So, yung table of values natin will be this, no? So, if we substitute these values of x sa ating equation, sa ating function rather, so we have this set of y values. So ngayon, dahil may set of y values na, pwede na nating i-plot ang ating mga ordered pairs. So kapag ipa-plot na natin, the graph will look like this. Now, kung pansin ninyo, mas ma-identify na natin ngayon kung ano yung range ng ating rational function na f of x equals x squared all over x squared minus 9. So in this case, ang range natin ay nahahati sa dalawa. So ito, sa baba, itong parabola sa baba is the set of y values such that y is less than or equal to 0. So lahat ng maliit sa 0. Yun, the set of y values such that y is greater than positive 1. So, ibig sabihin pala, yung kaninang graph na pinag-uusapan natin na ganito, ang function niya ay f of x equals x squared all over x squared minus 9. So, dito, pagkatapos nating na-graph, ma-identify agad natin kung ano yung set of range natin. Samantalang ang domain, pwede lang natin i-calculate algebraically. Klaro na ba yung iba't ibang methods or ways kung paano sinusolve ang ating range ng rational function? This time, if naintindihan ninyo ang lesson na ito, determine the domain and range of each rational function. Kapag tapos na kayo, type your answers on the comment section. Kung nakatulong ang Mathusay math tutorial na mas madaling maintindihan ang inyong lesson about finding the domain and range of a rational function, give this video a thumbs up, share, and subscribe to my YouTube channel. Remember, ang sekreto para maging mathusay, matuto, at mag-ensayo. Abangan ang susunod na episode at matuto kung paano sinusolve ang asymptotes ng rational function. Kita-kits! Bye!